Dear students, yesterday we discussed about mean value theorems. First one is Rolle's mean value theorem and second one is mean value Lagrange's mean value theorem. Yesterday we solved some problems on Rolle's theorem. We verified some functions and conditions for Rolle's theorem, and by Rolle's theorem we get the value of C at function. Today we shall study about Lagrange's Rolle's theorem, Lagrange's mean value theorem. Mean value theorem. This theorem is simply known as mean value theorem. We say that as mean value theorem. Verify mean value theorem like this. Mean value theorem is extension of Rolle's theorem. It's a little bit different from Rolle's theorem. In Rolle's theorem, we have verify the three conditions. If it satisfies these conditions, then we say that Rolle's theorem is satisfied. Here also three conditions are there. First, we know about the definition of mean value theorem. Let f of x is a function from a to closed interval a b to r be a continuous function, be a continuous on continuous function on closed interval a b and differentiable. These two conditions in the Rolle's theorem also on open interval AB. Then there exists some C such that f dash C, which is equal to f of b minus f of a divided by b minus a divided by b minus a. This is the definition. Let f of x is closed interval from a to b, from AB to R, be a continuous function. It's a domain and it's a range, and it's differentiable on open interval AB. Then there exists some C such that f dash C is equal to f of b minus f of a divided by b minus c. I will discuss this by geometrical interpretation. Geometrical interpretation of Yamuni. If this is the curve or graph of the function y is equal to f of x. Here it's a and there is B. It's the chord. We join A and B. The coordinates of A is equal to A f of B. A and f of B. X coordinate is A and Y coordinate is f of B. Here B f of B. Coordinates of A f of A, and coordinates of B is B f of B. Then we draw the tangent. We draw the tangent at C. C is f of C. These are the, we draw the tangent at C. At C, coordinates are C, F, C. The three tangents are parallel, here and here and here. Three tangents are parallel. C is clearly slope of AB, chord AB is equal to f of B minus f of A divided by B minus A. It's nothing but differentiation of or derivative of this function f of x. Therefore, we write it as f dash x is equal to f dash c. Here it is f dash c. Because these three are parallel to each other. Three chords are tangents are parallel. Therefore, the MD states that at the point C, AB such that slope of tangent C f of C and same as the slope of the tangent slope or tangent of the point at point A and B are parallel or slopes are equal. Therefore, they are equal to and plus C. Here also, to verify Riemannian theorem, we first the three conditions satisfy, two conditions satisfied or not. First one is continuous function, second one is differentiable on AB, and then find f of B and f of A. It can be derivable or definable between A and B. All these conditions satisfied, then we find the f dash c, and where it is the tangent is there, find the value of c. Find the value of c by f dash is equal to f of b minus a, f of a divided by f of a b minus a. By using these, we find the value of c, which is belongs to open interval a. I think you hear about the geometrical interpretation. Here it is x is 0. We draw the graph here. It may be this type also. This type also. Here it may be this A, this B. Then we draw the tangents here. Here P, Q, R, three slopes at P, Q, R are equal to the tangents at slopes at A and B also. Therefore, it has 3 points. Here, they are all equal. Therefore, at least one point C such that f dash is equal to f of b minus f of a divided by b minus c. It will be more than one point also. Now we verify some functions. Mean value theorem. Verify the mean value theorem for some functions. We will take simple problem. First one. Verify mean value theorem for the function f of x equal to x square in the interval 2 4, closed interval 2 4. First we check the continuity and differentiability. First one, since the function f of x is equal to x square is polynomial function. Therefore, it is continuous on AB, closed interval AB. We write in the already wrote in the Rose theorem also. Here also. Then f of x equal to x square, f dash x is equal to 2x. Therefore, the function is differentiable. On open interval A. Two conditions are satisfied. Then we find f of A and f of B. F of A. We have to find the value f of A is x square, where f of A is 2. Is equal to x square. 2 square is equal to 4. Then f of b, which is equal to f of 4, which is equal to 4 square, is equal to 16. Then we find the by Amity theorem. These are exist. Then we find the by Amity theorem. There exists. The symbol implies there exists. C belongs to 2 4 such that f dash c, which is equal to f of b minus f of a divided by b minus c. F dash c is equal to f of b minus f of a divided by b minus a. In Rose theorem, we find f of a and f of b, they are equal. Then only we find the value of c. Here, we find the value by f dash c, but f of b minus f of a divided by b minus a, they are not equal. Then f dash c is equal to You already know. It's f of f dash x equal to 2x. F dash c is equal to, you replace x by c, it's equal to 2c. Therefore, I put these values in f dash c. 2c, which is equal to f of b is 16 minus 4 divided by b minus a. B is 4, a is 2. Therefore, 4 minus 2. Therefore, 16 minus 4 is equal to 12. Then 4 minus 2 is 2. 3 is equal to C is equal to 2c is equal to 3. Therefore, 3. C is equal to 3 by 2. 3 by 2 is belongs to 2, 4 because 3 by 2 is 1.5, which is equal to 1.5, which is belongs to 2, 4. This is not good. 6 by 2. 6 by 2, which is equal to 3. It should be belongs to this interval, open interval 2, 4. But 1.5 is not belongs to 2, 4. Therefore, I conclude that this is right answer. C is equal to 3. Continuity on A, closed interval AB. Then differentiability on open interval AB. Then find the value of f of A and f of B. Then f dash by MUT theorem, f dash C we find that which is equal to this derivative with respect to C. We equate these two. We get the value C is equal to 3, which is belongs to 2, 4. Then only MUT theorem. If it's not belongs to 2, 4 interval, open interval 2, 4, MUT is not verified. We check on 2 more problems. Verify mean value theorem for function. Second example. F of x equal to x square minus 4x minus 3. If x equal to x is belongs to 1, 1. Here also we follow the same steps. First one is see the function f of x, which is equal to x square minus 4x minus 3 is polynomial function. Is polynomial function. First, therefore, it is the function is continuous. Write continuous on open closed interval 1, 4. You should write the interval also. Then second step, f of x equal to x square minus 4x minus 3. Here f dash x equal to 2x minus 4 which is differentiable. Therefore, the function is differentiable on one foot. Then we find the f of a and f of b. F of a is equal to f of 1. 1 is here, the first interval is a, is b. 1. Put the values in the here, not f dash x. Put the value in f of x. F of 1 is equal to 1 square minus 4 into 1 minus 3. Then 1 minus 4 minus 3, which is equal to minus 7 plus 1 is minus 6. F of 1 is minus 6. Then f of b, which is equal to f of 4. 4 square minus 4 into 4 minus 3, which is equal to 16 minus 16 minus 3, which is equal to minus 3. Yes, answer is minus 3. Here f of 1 is minus 3. Then by MBT theorem is derivable. Then by MBT theorem. By MBT, we get f dash c. There exists c such that belongs to 1 4, such that f dash c is equal to f of b minus f of a divided by b minus a. Here f dash c is equal to, already find f dash x. F dash c is equal to 2c minus 4. 2c minus 4, which is equal to f of b is minus 3 minus of this also minus 6. Then 1 4 minus 1, b is 4 minus 1. Then minus 3 plus 6 divided by 3, which is equal to 6 minus 3 is 3, 3 by 3, which is equal to 1. It is equal to 1. 2c minus 4 is equal to 1. Therefore, 2c is equal to minus 4 taken in the RHS side, which is equal to plus 5. C is equal to 5 by 2. C is equal to 5 by 2. 5 by 2 means 2.5. 2.5 belongs to 1/4. Belongs to 1/4. That means MBT theorem verified. Hence, MBT is verified. Consider there exists C 1/4. We find the value by f of b minus f of a. It's 2c minus 4 is equal to minus 3 minus 6. Minus 6. Then 4 minus 1. It's a minus 3 plus 6 divided by 3. It's just we get 3 by 3 is equal to 1. It is equal to 1. Therefore, 2c minus 4 is equal to 1. Therefore, c is equal to 5 by 2. This belongs to 1/4. open interval. That means the additivity theorem is verified. We solve one more problem. The same steps followed in the all problems. In the Rose theorem, little bit different. In Rose theorem, f of a is equal to f of b, but in MVT theorem, they are not equal. Verify mean value theorem for the function f of x equal to x cube minus 5x square minus 3x. X cube minus 5x square minus 3x in interval AB, where A is equal to 1 and B is equal to 3. Find all C, right? All C belongs to 1, 3, for which f dash C is equal to. Here f dash C is equal to 0 means that is equal to 10. So for 10 this is parallel. The third problem. Next, here also we find the continuity since the function f of x is polynomial. Because x cube minus 5x square minus 3x, therefore it is continuous function on closed interval 1, 3. Second one, f of x equal to, here two steps are in order, x cube minus 5x square minus 3x. We find the differentiation with respect to x. Therefore, f dash x is equal to 3x square minus 10x. So, x to the power n derivative is already known about n into x to the power n minus 1. Therefore, 3 into x to the power square 5 into 2x minus 3, which is equal to 3x square minus 10x minus 3. It's f dash x. Then we find the f of a value and f of b value. F of a is f of 1 is equal to, f of 1 is equal to 1 cube minus 5 1 square minus 3 into 1, which is equal to 1 minus 5 minus 3, which is equal to minus 7. Minus 8 plus 1 is minus 7. F of a is equal to minus. F of b is equal to f of 3. We substitute the value of 3 in the f of x. Replace x by 3. 3 cube minus 5 into 3 square minus 3 into 3. Okay? 27 minus 45. 9 into 3 square is 9. 9 into 5 is minus 45. 3 into 3, 9, which is equal to 45 minus 45 minus 9 is equal to minus 54 plus 27. It's equal to 7. So 27. It's a minus. F of b is minus 27. Then by mean value theorem, or MVT, there exists C such that belongs to AB, such that f dash c, which is equal to f of b minus f of a divided by b minus. Here we put the value of f dash c. I write it as 3c square minus 10c minus 3. Write this value 3c square minus 10c minus 3, which is equal to f of b is equal to minus 27 minus of f of a is equal to minus 7 divided by f of a is equal to b minus a, b is 3 minus 1, which is equal to minus 27 minus of minus 7 is minus 27 plus 7 divided by 2. It's a 20 by 2. Minus 27 is minus 20 by 2, which is equal to minus 10. Here LHS is 3c square minus 10c minus 3. We equate these, we get I write here 3c square minus 10c minus 3, which is equal to minus 10. Then 3c square minus 10c minus 10 becomes plus 10 in the LHS side. Therefore, plus 10 minus 3 is equal to plus 7, which is equal to 0. Here we split this 10c into 7c, 3c, then we get 3c square minus 3c minus 7c. 7 into 3 is 21. Here also 7 into 3 is 21. 7 minus 7 minus is plus. Then 3 minus 3c minus 7c. Algebraic sum is minus 10c, which is equal to plus 7, which is equal to 0. Then we take common factor 3c, c minus 1 minus 7, c minus 1. We get or take common minus sign, therefore we get c minus 1. Therefore c minus 1 and 3c minus 7, which is equal to 0. C minus 1 is 0 or 3c minus 7 is equal to 0. C is equal to 1 or c is equal to 7 by 3. C is equal to 7 by 3. Here c is equal to 1 and c is equal to 7. Which one is belongs to 1 3? We have to find. Here 1 is not belongs to 1 because 1 is not included here. 1 is not included here. It's open bracket. But 7 by 3, which is equal to 2.7. 2.37, which is belongs to 1 3. Therefore, 7 by 3, c is equal to 7 by 3 is belongs to 1 3. Therefore, the function is c value at 7 by 3 MUT theorem is verified. Is verified. It's not belongs to c. We will take this value only. 7 by 3 is belongs to 1 3, which is by this the MUT theorem is verified here. You solve some other problems and from other book. Some small problems are there. If it is verified or not. Some in the greatest integer function. We check the MUT theorem at any interval. We can't verify the MUT theorem because it's not continuous function. You already know about the continuity of the function. Then the function is not continuous. Then the function is not satisfied the MUT conditions or Rolle's theorem conditions also. For greatest integer functions Rolle's theorem and MUT theorem is not verified. In you face one problem in annual exam, 3-mark question, either on Rolle's theorem or mean value theorem. It's a 3-mark questions. You should write all the steps. It's a passing paper question. Therefore, all the students should practice this problem. In every question paper, there will be one question on this type. And write one more problem which is not examining the applicability of MUT for the function f of x equal to x for x is equal to 5 9. Here this type is denotes this function denotes greatest integer function. It's a greatest integer function. You already know about greatest integer functions are not continuous functions or discontinuous at integral points. Because 1.5 greatest integer is 1 and 2.1 is 2. But 1.9 also is 1. Therefore, the function is always discontinuous in the integral points. Therefore, the function is greatest integer functions are, we know that function is not continuous and not derivable also. Not derivable also. Therefore, the conditions of MVT are not satisfied. Not satisfied. These two conditions are, or one condition is not satisfied, MVT theorem can be verified. MVT theorem not verified. I think I finished the continuity and differentiability as per as your syllabus. I discussed some problems in the class. You solve many problems or practice in the home. Then only you perfect the finding the different derivatives of functions if they will give any function. It may be implicit, explicit, and logarithmic. Anyway, you find the differentiate or derivative perfectly. First you perfect the formula, then you try to solve some problems without knowing the other problem. You yourself only you have to practice. Don't take others help or notebook. Close your notebook and practice your many problems. Then only you perfect. In the question paper, many problems are from continuous and differentiability. In the continuous functions, there will be 4-mark question will ask in E-type question. E-type question. In differentiability, 1-mark question, 2-mark question, 3-mark question, theorem 1 or Rose's theorem, and other one is parametric function. Other one is parametric functions, etc. There also for CET questions, many problems will ask on this chapter. Therefore, in higher studies, it is very essential chapter. Therefore, in the physics, chemistry also it's taking the help of this differentiability or differentiation in the your other course also. Therefore, you practice this chapter very perfectly. If you don't understand, please watch the videos 1 or 2 times or 3 times. Then you perfect the or you clear about the doubts. If you have many doubts in your mind, if you ask me in WhatsApp or other by call also,
I will ask or solve some problems by that also. I will give you PDF. Don't write the PDF without knowing the or watching the videos or class. You can't understand this. You without watch the videos, you can't understand. You have books, no? If you otherwise we don't take the class. Therefore, you practice very well in the room, then safe home and practice well. Thank you.